In this video lecture, I am going to cover the concept of functions. So here we have seen what is relation. So if I say there are two non-empty sets A and B, and there is a relation R from set A to B, so we say that R is a subset of A cross B. Okay, and if we say R is a relation on A, that means R is a subset of A cross A. And we have seen we can represent the relation in terms of ordered pair, matrix, and directed graph. Now, what is function? If I say I have two sets A and B, and there is a function f from A to B, so it will be represented by represented like this. F is a function from A to B. So that means each element x in A is having exactly one element y in B. Means if I say there is a function from A to B set, so A is suppose having 3 elements, B is suppose having 4 elements. So all the elements, each element of the first set should be associated with some elements of set B. That is function. Okay, so we'll see more formal definition of the function. For non-empty sets A and B, a function or a mapping, we can also call it mapping, f from A to B, denoted by f such that A tends to B. So that means this is how we represent the function. If I have written f A to B, that means it represent there is a function f from set A to set B, and it should be non-empty set always. For relation also it should be non-empty set. For function also both the sets should be non-empty sets. Okay, so if we say that there is a function f from A to B, so it's a relation from A to B in which every element of A appears exactly once as a first component of an ordered pair in the relation. So basically, what does it mean? We say that a relation means a relation. It's a relation only where each element of the first set appears exactly once. Okay. So what does it mean? That we will see using example. Suppose if I say A is equal to 1, 2, 3, 4, B is equal to A, B, C, D. Okay. So elements of A are 4, A 1, 2, 3, 4. The B is having 4 elements, A, B, C, and D. So according to the definition, it should be non-empty set. So A and B both are having 4 elements. So it is non-empty. And we are saying there is a function f from A to B. So we are saying that it's a relation in which every element of A appears exactly once as the first component of an ordered pair. Every element of A appears exactly once. So if I say R, okay, so here I have 4 ordered pair, 1A, 2B, 3C, and 4D. So see, in each ordered pair, the first element, so each element of A means 1, 2, 3, 4, it appears as a first component of the ordered pair. So it is appearing, see here 1, then 2, then 3, 4. So each elements of A are appearing as a first element of an ordered pair. Okay, so that means R is a function. Now, if I say S, so S I have 1B, 1D, and 2D, right? So each element of A means 1, 2, 3, and 4, all I have to see, right? So 1 and 2 is appearing, see 1 is appearing twice here, right? So that means 1 is, in this ordered pair, I have 1, and in the second one also I have 1. So 1 is appearing more than 2, more than once, more than 1. So twice it is appearing. So that means it is not a function. So according to this definition, I can conclude as R is a function, S is not a function. We'll see in more, if we see this definition, it will be more clear. Now we say that we write like this, FA is equal to B. So what does it mean, FA is equal to B? If I am writing, that means B is the image of A. Okay, so what is the meaning of image of A? So here, if I see the ordered pair, so I can write f of 1 is equal to A. So that means the image of 1 is A. So in each ordered pair, the first element is what I can write like FA, and the second element is nothing but the image of the first element, or I can say the first element is nothing but the pre-image of the second element. Okay. So that only is written here. FA is equal to B when AB is an ordered pair in the function. So AB belongs to F means this AB is nothing but the ordered pair. If it belongs to F, B is called the image of A under F. So this B means the second element is nothing but it is called the image of the first element, and A is the pre-image of B, and the first element of each ordered pair is called as the pre-image of the second element. Okay, in addition, the definition suggests that F is a method for association with each A belongs to A. The unique element FA is equal to B belongs to B. So one more thing we have to remember. First thing is what? Every element of first set should be associated with some element of B. Okay, and each element of the first set should be having only one image in the second set. Okay. These are the two basic conditions for a relation to be a function. So any relation, if I have to find out whether it's a function or not, so these two conditions should be satisfied. First condition is what? Every element of the first set should be associated with some element of the second set. Second condition, each element of the first set should be having only one image in the second set. So one element cannot have more than two images. So, and see, in each ordered pair, first element is called as the pre-image of the second element, and the second element is called as the image of the first, image of the first element. Yeah, correct. So now see, in this, according to this definition, I can say see here I can say A is the image of 1, B is the image of 2, C is the image of 3, D is the image of 4. So each element 1, 2, 3, 4 of set A is having exactly one image in set B, and each element of A 1, 2, 3, 4 is appearing in the relation, right, exactly once. And see, for B it is not required for a relation to be a function. We are not seeing each element of B should also be associated with some element of A. We have to just check each element of A should be associated with some element of B. Okay, so here see, A, B, C, D all are coming, but it is not necessary for B. Now in S, see here, this means B is the image of 1, D is also the image of 1. So see, second condition of the function is not satisfying here, because that means 1 is having image B and D both. So any element cannot have more than two images. That is the meaning of this line. With each small a belongs to capital A, the unique element f of A is equal to B belongs to B. Means every element of the first set should be having the unique image in the second set. So these two conditions, first every element of A should be associated with some element of B, and every element of A should be having unique image in B. These are the two conditions for a relation to be a function. Okay. So now I think it is clear why R is a function, whereas why S is not a function. Okay. Now next is here we are saying we have two non-empty set A and B. So here A is called as domain and B is called the codomain. Okay. So the subset of B consisting of those elements that appear as second component in the ordered pair of F is called the range of F, and is also denoted by FA because it is the set of images of the elements of A under F. Okay, so what does it mean? Here if I say this example, so see, in relation also I have told if I have to find the domain and range. So domain means the first element of each ordered pair I am going to pick. Range means the second element of each ordered pair I am going to pick, right? So if I have to find the range for this relation, what will be range? It will be A, B, C, D. Here, since it's not a function only, so I will not check. Okay. So range is nothing but the image of the element. So that is nothing but the second element of each ordered pair. I'm going to write as a range of that function. Okay, now we'll see some examples and we will try to identify whether these relations are functions or not. So first one, F is 2, 3, 1, 4, 2, 1, 3, 2 and 4, 4, and the set is also given. A is equal to 1, 2, 3, 4 and R is a relation on A. Okay. So R is a relation on A means R is a subset of A cross A, and this is some relation given. Now we have to find whether it's a function or not. Okay. So the first condition of function is what? Each element of A should be associated with some element of B. So each element of A means 1, 2. So in each, here in ordered pair, each element of A should appear as the first element. Okay. So here see, 2 is coming, 1 is coming, here 3, 4 all are coming, but the second condition is what? Each element of A should be having unique image in B. So here 2 is having image 3, 1 is having image 4, 2 is again having image 1. So see, for the element 2, it is having more than one images. So 2 is having image 3 and 1 both, that is not possible. So we will say that it is not a function. Okay, so these two conditions you have to check. Now the second question, I have 3 1 4 2 and 1 1. So 3 1 4 2 and 1 1. So here this is for different example. Here 3 to 1, 4 to 2 and 1 to 1. So each elements are having a unique image. Okay, so we will say that it's a function. Now if suppose some relation is given 2 1 3 4 1 4 2 1 and 4 4. Okay, so here 2 is having image 1 and 3 is having image 4, 1 is having image 4, 4 is having image 4. So each elements are having only one images. So this is also a function. And see, we have written 2 1 twice, so it won't make any difference. It's repeated, but both are same only. Okay, so this also is a function. Now if suppose a function is given and you have to find the range. Okay, so in this example, I have set A which has elements 0, plus minus 1, plus minus 2 and 3. Okay, and there is a function f from A to R. So A is this set and R is a set of all real numbers. Okay, so defined by this. So this is the function x cube minus 2x square plus 3x plus 1. For x belongs to A, find the range of f. So range I told if see these are the elements. So if I substitute 0 here, so what will be the value? This will be f0. Okay, then plus 1 if I substitute, that will be f1, then f minus 1, then f plus 2, f minus 2 and f3 I have to find, and whatever result I am going, that is going to be my range. So f0, I'll substitute the value of as x as a 0, and then I'll find the function value. It is coming 1. Then f1, it is coming 3, f minus 1, it is coming 7, f minus 2, it is coming minus 21, and f3, it is coming 19. So range will be 1, 3, 7, minus 21 and 19. Okay, so I hope it is clear. Now let's take one more example. This is similar to the previous question only. So I have to find the range. So range f0, f plus 1, f minus 1, f2 and f minus 2 I have to find. So range I will calculate the values, and 1, 3, 7. So this will be the range of the function. So next class I will discuss types of function. Thank you.